All right, so we're about 2 minutes after. We're going to go ahead and get started. This is being recorded. We will post it on the St. Mary's Riverkeeper website soon once I am able to figure out how to do that. We also have live transcription, so closed captionings have been enabled. But let's go ahead and get started. Good afternoon, everyone. Thank you for joining us today for the kickoff of our For Our River educational webinar series. My name is Emily Floor, and I'm the Executive Director for St. Mary's Riverkeeper. Today's webinar is an opportunity for everyone to learn more about the connection between Trail Ridge, the Okefenokee Swamp, and our St. Mary's River, as well as the impacts the proposed mine may have on our watershed from swamp to sea. This is just the first of a few webinar series to address and hopefully answer some of the complex issues regarding the water levels of the swamp, river, and groundwater systems brought up by scientists, other conservation organizations, and concerned citizens. Each episode will focus on a specific topic with different subject matter experts and allow time for discussion from our participants to help us better understand each topic. Today, we are joined by Dr. Rhett Jackson from the Warnell School of Forestry and Natural Resources from the University of Georgia, and we will dive into the geologic history of Trail Ridge and its role in forming the Okefenokee Swamp and St. Mary's River. His expertise has also provided insight into the potential impacts of mining near the swamp and river. But before we do that, we're going to discuss St. Mary's Riverkeeper's work to protect the St. Mary's River, our efforts to monitor and educate the public about the health of our river, and ways you can engage today. We will then hear from our guest speaker and end with Q&A from our viewers. So who are we? To begin, we are going to talk about St. Mary's Riverkeeper to discuss who we are and what we do to ensure our river is protected. Founded in 2016, St. Mary's Riverkeeper is an independent voice for the St. Mary's River dedicated to improving water quality in areas that are designated as swimmable and fishable, ensuring the river thrives for future generations with our work on resiliency projects and community partnerships, promote low-impact development in a fast-growing area, finding solutions for water-related issues in the watershed, and advocating against industrial threats in our underserved communities. As a trusted voice for the St. Mary's River, Riverkeeper fulfills its mission by investigating pollution problems and seeks solutions that protect our river, ensuring environmental regulations are implemented and enforced, advocating for the protection of our river and participating in the decision-making process to represent the interests of the river, our members, and the public, educating the public with the St. Mary's River and the issues impacting its health, providing frequent opportunities for people to experience and serve their river through boat rides, field trips, and river cleanups, and engaging with citizens to effectively resolve problems impacting the river in their neighborhoods and communities. As a border river, the St. Mary's River watershed is comprised of 4 counties, 2 in Georgia and 2 in Florida, with roughly 60,000 residents who depend on the health of the river for tourism, recreation, commercial fishing, and safe drinking water. Arising from the Okefenokee Swamp, the St. Mary's River flows 130 miles to the Atlantic Ocean at Cumberland Island National Seashore. The watershed is more than 3,000 miles of streams and tributaries, comprised of 40% wetlands, and is home to many endangered and threatened species such as the Atlantic and short-nosed sturgeon. The shape of the St. Mary's is defined by the natural break in Trail Ridge. The Okefenokee Swamp and the uppermost section of the St. Mary's runs along the western side of Trail Ridge. The river then turns eastward for about 15 miles as it makes its way through the only gap in Trail Ridge, and then it heads north for about 30 miles running along the eastern side of Trail Ridge before turning east at the Folkston, Georgia or Hilliard, Florida area to head out to the Atlantic Ocean. The southeastern corner, about 20% of the swamp, feeds the St. Mary's River, which results in the upper river having zero flow at times and flooding at others. From swamp to sea, the St. Mary's is pristine. The land along the St. Mary's is mostly entirely privately owned by timber plantations, conservation districts, and private citizens. In 2022, Georgia DNR declared 2 segments of the St. Mary's River safe for recreational use: Deep Creek to Boone Creek and Prospect Landing Road to Little St. Mary's. This upgrade means the segments are safe for general recreational activities such as water skiing, boating, swimming, and recreational fishing. Some of our efforts to ensure our river is protected include our extensive water quality monitoring program, where we test for chemical parameters such as dissolved oxygen, pH, salinity, conductivity, as well as bacterial parameters for E. coli. With a lot of septic in the region, we want to make sure that all the septic are kept up to date. Our river cleanups, we have a big river cleanup every single year where we pull 8 tons of trash out of the river on one day, and then we have a few smaller ones throughout the year. Our experiential learning opportunities, which we have paddle trips, bike rides, boat rides, birding opportunities. Our river enhancement projects, such as our Living Shoreline project, and then of course our advocacy and engaging opportunities. Some of the upcoming events that we have is our currently our mining public comment, which closes March 20th. We're going to talk about that in a little bit. Our St. Mary's River cleanup, this is the big one, on April 15th. Our boat tours, we have 2 of them coming up March 4th and March 11th from 10 a.m. to 12 p.m., departing and returning to Traders Hill Boat Ramp in Folkston, Georgia. And then our citizen science training, where if you're interested in doing learning about our water quality testing and want to participate in that, you can be trained in the Georgia Adopt a Stream standard operating procedures to be able to do that. And you can visit our website to learn more and to register. But now I'm going to turn it over to Dr. Rhett Jackson to talk about what we are here to learn about today. So I'm going to introduce you real fast, Dr. Jackson. Dr. Rhett Jackson is a John Porter Stevens Distinguished Professor of Water Resources at the Warnell School of Forestry and Natural Resources at the University of Georgia. Dr. Jackson's research focuses on the effects of human land use activities, specifically forestry, agriculture, and urbanization, on water quality and aquatic habitat. He conducts applied research into the effectiveness of best management practices in reducing non-point source pollution, erosion, and flooding. He also conducts basic research into the subsurface routing of water and solutes from hills to stream, and this work helps us understand how, where, and under what conditions pollutants move to streams. A particular current interest are the relationships between riparian vegetation, channel structure, stream temperatures, and aquatic habitat. He is a member of the Institute for Resilient Infrastructure Systems and the River Basin Center at UGA. Dr. Jackson has published over 100 peer-referenced publications and has earned a BSc and MSc degrees in civil and environmental engineering from Duke University and a PhD in environmental engineering from University of Washington. Prior to becoming an academic, Dr. Jackson worked as a stormwater management environmental consultant. His memos and responses and scientific expert has provided opportunities for the community to understand the potential impacts and issues around the proposed mining project from another scientific viewpoint. His questions around Georgia EPD's approach for issues including the water level gauges in the St. Mary's River have raised concerns around why certain topics are being considered or used. He brings up other concerns around salts in the air from the proposed evaporator so that the mining company can have a closed loop system for water and not discharge into a water body. So I'm going to turn it over to you, Dr. Jackson. Thank you so much for participating with us today. And thank you to everyone that joined us for their lunch and while they're eating to be able to learn about this issue. Thank you.
Thanks, Emily. Good afternoon, everybody. Thanks for being here. I want to say before I get started that if you want to interrupt me while I'm going to ask me a question, that's cool. I assume that probably most of you have been to the swamp, but I'm going to start out with like 4 or 5 pretty slides in case you haven't been to the swamp so you can understand like how amazingly beautiful the swamp is. And some basic facts about the swamp is that the present incarnation of the swamp is about 6,500 years old. This current swamp didn't form until after the last ice age. It's mostly within the Okefenokee National Wildlife Refuge, which receives over 600,000 visits each year. And one of the cool things about the swamp is it's got 120 miles of canoe and kayak trails, which really should be appreciated. And, you know, the swamp is just really cool. It's got 21 different habitat types. It's got huge biodiversity. It's also just phenomenally pretty, as you can see from these images. And another cool thing about the Okefenokee is that it has the darkest skies, night skies on the East Coast, south of the Canadian border. So if you go there on a moonless night, on a clear moonless night, it really is quite remarkable. So, you know, some of the things I said, we got over 200 bird species in the swamp, 64 reptile species, 37 amphibian species. Some of these species are on the threatened and endangered list. It's a bird migration hotspot, has peat deposits that have built up over time. They're now up to 15 feet deep. It is a candidate UNESCO World Heritage Site. I'll say one of the problems with the swamp is that there's not enough lodging or campgrounds. So there's very few places like get a cabin near the swamp, like Stephen C. Foster State Park is one of them. But if you want a weekend cabin, you're going to have to book 6 months in advance. So all I really want to impress upon you in these first slides is that the Okefenokee Swamp is not just a Georgia treasure, it's an international treasure. People come from far and wide to see this place. And we really need to develop the tourist potential and essentially the tourist infrastructure for the swamp. So one of the things that's really important to understand about wetlands is that they're not randomly distributed in the landscape. They are created by specific geological processes. For example, glaciation, sea level change, river meandering, tectonic uplift, limestone dissolution. And approximately half of the wetlands in the US have previously been filled or drained for agriculture, things like harbor development, construction, mosquito abatement. And the Okefenokee Swamp, besides being really beautiful and a great center of biodiversity, it also plays an important role in the Atlantic flyway for bird migration. So let's think about why the swamp is there. So this is a cross section looking north. And so the left side is west and the right side is east. And you can see Trail Ridge as being really big and tall compared to the swamp. And Trail Ridge is essentially, it's an old barrier island, and it essentially acts as an earthen berm that dammed up a basin that would otherwise flow from west to east through Folkestone to the sea. But because Trail Ridge is there, it dams up the small tributaries that come into the swamp, and it dams up the water that falls into the swamp as rainfall and creates the swamp itself. So we can look at these old barrier island features from when sea level is higher, and there's a lot of them on the Atlantic coastal plain. So over there on the left, I don't know if you guys can see my cursor, but this long ridge here on the LiDAR hillshade map is Trail Ridge. And you can see that right here, it's got a little notch in it, and that's where the St. Mary's passes through. And where'd my cursor go? Here it goes. This flat spot here is the Okefenokee Swamp. And we can look at this black and white hand-drawn map, and it shows all the different barrier islands that are on the Georgia coast that have been left behind as sea levels have fallen over time. Some of these barrier islands are quite old. Trail Ridge is unusual due to its extreme length and height. It's very different from these other remnant barrier island features on the East Coast. So let's look at the setting of the Okefenokee Swamp. So these are maps created by the U.S. Fish and Wildlife Service for the refuge. And on the left, one of the things you can see about the swamp is that it's actually got very complex microtopography. And the other weird thing about the swamp is that it drains to two different rivers. So the sort of the northern and western side of the swamp and the bigger part of the swamp drains to the Suwannee River, which is now going to flow through Florida and come out in the Gulf. And the eastern and southern part of the swamp drains to the north prong of the St. Mary's River. And when the swamp is wet and water levels are high, it's kind of like all one water body. But when the swamp water levels start dropping, the swamp sort of becomes compartmentalized. And that's what's shown in the right map is sort of the 6 compartments that the Fish and Wildlife Service has identified. And the mine that is now proposed basically directly affects the southeast and indirectly affects that southwest quadrant. I will tell you right now that the mine is very unlikely to affect the Suwannee River. But for that southeastern and southern portion of the swamp, the mine is going to potentially have very significant hydrologic effects, as I'll get into. So this is a map from the Georgia River Network showing the water trails that are within the Okefenokee Swamp. And it also shows the Twin Pines mine site and the main stem of the St. Mary's River to kind of give you a good overview of where we're talking about. So as Emily said in her introduction, currently the swamp is mainly surrounded by commercial forests, blueberry farms, and state forests. Up till now, the swamp has pretty much had a perfect buffer. Like if you were designing the Okefenokee National Wildlife Refuge and you got to pick what land uses you wanted around the swamp, this is exactly what you'd pick. These low intensity land uses with very little water quality effects, very little sedimentation. It's great, but that could potentially change. So here's a zooming in on the mining site and Trail Ridge. So this is a topographic map that's color coded. So the red is high elevations, up to 77 feet here. And the blue purples are low elevations. So the lower St. Mary's River is over here on the right side of this map. You can see where the wildlife refuge is here. It's mapped. And this polygon with diagonal lines through it, just above State Route 94, is the current mine site, proposed mine site. And what I want you to get out of this graphic is that the mine site sits on the very crest of Trail Ridge. And so if we go to the east side of Trail Ridge at the mine site, we're draining into Boone Creek, and that's going to flow down to the lower St. Mary's. And if we're on the west side of the mine site, water is going to flow into the tributaries to the River Styx and then into that southeastern compartment of the swamp. And there's also a groundwater divide that runs through here, such that groundwater on the west side is running to the swamp and groundwater on the east side is running to the lower St. Mary's. If we look at this site from a satellite, this is actually what was defined as wetland by the National Wetland Inventory by the U.S. Fish and Wildlife Service. And what you can see is there's a, even with this rough coarse scale aerial photo mapping, that the Trail Ridge itself has a lot of these depressional wetlands. When we zoom in on the mine site and people actually go out and delineate the wetlands on the ground, we find that over half of the mine site is wetland. Now, one of the things that is interesting about this permitting history is that Twin Pines Minerals LLC originally proposed this mine while the Clean Water Rule, which is an interpretation of the extent of the jurisdiction of the Clean Water Act, was in effect. And all of these wetlands that are on the mine site were deemed jurisdictional under the Clean Water Rule, which meant that under that rule, the mine would have had to go through federal wetlands permitting. The Trump administration changed that rule to something called the Navigable Water Protection Rule. And the intent of the Navigable Water Protection Rule was to decrease the extent of jurisdiction under the Clean Water Act and to basically remove Clean Water Act protections from small depressional wetlands high in the landscape and from ephemeral or short running streams. And under that new interpretation, none of these wetlands were deemed jurisdictional. So this actually really changed the permitting environment for Twin Pines. So they got, during that window when the Navigable Water Protection Rule was in effect, which is only a little over a year or about a year, none of these sites were deemed jurisdictional, and they have to go through no federal wetlands permitting, which took them straight to the state. And it also means that there is no protections for these wetlands, or particularly any real requirement that they restore them afterwards. So what's the mine proposing to do? So these are just taken out of the mining land use plan. So on the right, what you see is they're basically going to create a mining pit that's 100 feet wide and 500 feet long. That's its bottom area. The top area will be greater because of the side slopes. And they're just going to go back and forth from one property line to the other, pushing this 100-foot by 500-foot and 50-foot deep excavation pit. And they plan to backfill as they go. So the way a mineral sands mine works, there's only a fraction of the sand that's actually valuable. If they're very lucky, that fraction is like 5 or 6%. If they're unlucky, that fraction is like 2 or 3%. So what they'll do is they'll take that sand out, they'll take it to a processing mill, and they'll basically separate the mineral sands out, and then they'll take the sands that they don't want, they're going to put them back in the pit. And they're going to just keep moving back and forth. You can see in the upper left that sort of Neapolitan ice cream looking polygon. That's year 1, 2, 3, and 4. And the lines going back and forth are just the planned route of the drag line going back and forth. Well, so they're going to be digging this big pit that's 50 foot deep into the superficial aquifer. And as long as that pit is there, water is going to be pouring from the superficial aquifer into the pit, just like it would into a big well. And the mine has estimated that they're going to have to withdraw 1.13 million gallons a day from the superficial aquifer constantly to dewater the pit. If we convert that to cubic feet per second, the preferred unit of American hydrologists, that would be 1.75 cubic feet per second. Put that number in your head because we're going to come back to it in a second. They also need to withdraw on average another 0.43 million gallons a day of processed water from the Florida aquifer below the mine and below Trail Ridge and below the swamp. The other thing is that they're going to take a very stratified stratigraphy and they're going to put back mixed sands. So the other thing about this mine is it's going to change the hydraulic properties of Trail Ridge itself. So that's the basic overview of how the mine works. Now here on the left, also taken from the mine land use plan, is the generalized geologic cross-section of the mine footprint. And sort of the burgundy polygon that drops down, goes across, and goes back up. That's what would be the mine pit when they were done. All that material would have been removed and replaced. And you can see that there's a big layer of these consolidated black sands in the middle of that area that's going to be mined. Well, that consolidated black sands has a very low hydraulic conductivity, which means it moves water very slowly. And so on the right, there's a concern that will cause the water table to drop on Trail Ridge in the post-mining condition and make it hard for wetlands to reestablish. So the mine's plan is to basically try and replace that function of the black sands by putting in a layer of bentonite clay. And that shows up in this fuchsia band across here. So as they're backfilling, they backfill a certain amount of the mixed sands, and then they're going to place clay on top of it, and they'll backfill with more sand on top of that. And the idea is to make this continuous layer of clay in the backfill as they move. But they're going to be moving 10 to 15 acres a month. So one of the things you're going to see is I have a concern about how practical this actually is. The other thing I want you to realize is that down here in the lower left is a typical profile of one of the wetland soils on the site. This is the Lynn Haven soil series. And this dark soil down here is what we call a spodec horizon, which really just means that a lot of organic matter from pine trees over 1 million years is deposited here. And this also reduces the hydraulic conductivity of the soil and causes water to kind of pond up near the surface. These topsoils will be stockpiled when they start the mine, and then they'll be pushed back over when they've regraded the site. But all this will now be mixed up. You won't see that layering as it is now. I'm throwing this in there just to give you an idea of how one of these mines will work. This is a Google Earth image from a few years ago of the Mission Mine on Penn Holloway Ridge north of Folkestone. I actually feel quite good about this mine in terms of its location and how it operates. One of the things you can see here is that if you look up at the top of this image, which is kind of covered by some zoom information, you can see there's like a big wetland complex that ran across the ridge, and they avoided it. These areas here have already been mined and planted. So the darker green it is, the longer the trees have been growing. Here, the trees have been recently planted. Here, they're basically pushing the soil back in place and getting ready to reclaim it. Here is a wetland area that they avoided, and here's where they're currently operating. One of the things that's very different about this mine is that they had to go through federal wetland permitting, so they've minimized their wetland impacts, unlike at Trail Ridge, where they don't have any federal wetland permitting and there's no state laws protecting wetlands, so they can just go back and forth from property line to property line. So here's kind of the hydrologic story before and after mining. So here's on the top is the before mining view of Trail Ridge. And so as I talked about, on the left side or the west side of Trail Ridge, the groundwater from Trail Ridge is flowing to the swamp. And on the right side, it's flowing to the lower St. Mary's. This is sort of all mixed sands and humates. On the top, there's this formation called the Hawthorne Formation with low conductivity below it. And there's the Florida aquifer below that. So one of the things that's ironic about the swamp is that it's really drought sensitive. While the swamp covers a large area, it's only about 0.5 meters deep on average. The typical residence time of water in the swamp is only 3 to 4 months. The swamp mostly gets water from rainfall. The 70% of the inputs are just from rainfall itself. So if it doesn't rain for a while, the swamp gets dry. And under current conditions, the north prong of the St. Mary's doesn't flow 3% of the time. Because during droughts, there's just very little groundwater support for the swamp. The other thing about drought conditions in the swamp is it's when fires form. The swamp is sort of famous for having wildfires form on its outer margins during droughts, and that's when it happens. Also, boating opportunities in the swamp go away when the water levels are quite low. So the lower schematic shows you what happens during mining. So they've got this pit here, and the pit will draw groundwater in from both sides. And since half the water will come from the west side and half will come from the west side and half will come from the east side, that 1.13 they're pumping out of this pit and putting into a pond would otherwise have flown to the swamp itself. And so what we're going to look at in a minute is what happens to the hydrograph of the north prong of the St. Mary's when you take that water out. We'll also get to later is like, okay, you might be asking, what happens to all that water they put into the ponds? Well, they have to evaporate it because they're trying to operate this mine without a discharge permit. Okay, so what happens to the stream flow as the north prong of the St. Mary's leaves the swamp? This is what a hydrologist calls a flow duration curve. And this is presented as a decedence curve, which means what we have on the x-axis is the fraction of time that a flow on the y-axis, that the flows are less than or equal to that flow. So for example, the 0.1 here means, and the blue is the raw data. The blue means that for 10% of the time, the flow is less than 1 cubic feet per second. For, this is a log scale. So 2, 3, 4, 5% of the time, it's less than 0.1 cubic feet per second. And 3% of the time, the flow is 0. If we take out half of the 1.75 CFS that the mine is withdrawing from the superficial aquifer, so we're taking out 0.87 CFS, that's this red line. And what we see is that the zero flow level goes from 3% of the time to over 9.5% of the time. We basically triple the frequency and severity of drought in the swamp by taking out that much water. It has no effect on the median flow, it has no effect on high flows. The mine will really only matter when the swamp is in drought condition, but then it will matter a lot. So, one of the things we see in the swamp is that we see fire during drought periods. So these are maps of the 2017 fire that came out of the swamp. The left map shows the ownership. So those green areas were owned by the federal government. These sort of orange and brownish areas were owned mostly by private timber companies. And this map on the right is within the swamp, a measure of the severity of the fire. Point is that fires are quite common in the swamp during drought periods. Now, one of the things that Emily alluded to is that EPD has decided that the effects of the water withdrawals are minimal and not to be concerned about. Well, the reason they made that estimation is that they're analyzing the effects of the withdrawals, not at the ammoniac gauge on the north prong of the St. Mary's where it leaves the swamp, but they chose to analyze the effects of the withdrawal down at the gauge north of McClenny, Florida, where the basin is 4.4 times bigger and the average discharge is 4.4 times larger. All right, so if we look at the McClenny flow duration curve, it's the orange-yellow curve you can barely see here under the green curve. And the green curve is removing 0.87 CFS. And so I agree with EPD that the mine is not going to have a significant effect on the St. Mary's River down at McClenny. But that's not the issue. The issue is whether the mine affects the swamp. And the only way you can get at that question is by looking at the ammoniac gauge. So this has been one of my contentions with EPD the last couple months. To put this in perspective, this is a map of the two watersheds, nested watersheds. So this yellow hexagon here is the ammoniac gauge, and this area with the diagonal lines is the drainage basin that leads to the ammoniac gauge. So the mine is right here. This is those southeastern and southern compartments of the swamp. And the McClenny gauge is this yellow triangle here. And you can see that now this is the entire basin, and the McClenny gauge is getting all this flow from the sort of the central highlands of North Florida, with a lot of groundwater support. So the flows at these two locations are in no way similar. If you look at these on Google Earth, this is the North Fork as it comes out of the swamp, as it passes under Highway 94. Here's Lacey's Country Store. Notice that all you see here is a riparian forest because the channel's not big enough to actually see. This is an aerial photograph or satellite photograph of the McClenny gauge, and you can see that you're dealing with a real river at that point. Now, Emily went out there and took some photographs, which are great. And this is left side is the stream, or the north prong of the St. Mary's up around the ammoniac gauge. And the right side is the river at McClenny. So it doesn't take a hydrologist to realize that these are two very different spots, which would lead you to very different conclusions. Now, I alluded to the fact that they're going to try and get rid of all this water by evaporation, that they don't want to have a discharge permit. So in the upper right here, they plan to put these 55 of these floating evaporator systems in the ponds. So these little things will float, and then it has basically a sprinkler head sort of on either side with these little paddles, and it tries to put out small droplets of water into about 10 feet off the water surface and use that to evaporate the water. And they're going to need to evaporate 1.5 million gallons a day, day in, day out, to keep from discharging to surface waters. This, to me, is basically an experiment. No tests have been done on site with mineral sands processed water or in this climate to see if this evaporation system will work. The tests that have been provided by the manufacturer use a different water with a different chemistry in a different climate, and they actually didn't use this style evaporator. They used a different evaporator. So I have a lot of skepticism about how well this would work. I also want to show you here on the left, this is a photograph of what processed waters look like. They're really high in humates. They look like an extremely dark tea. They're kind of greasy to the touch. They have so much organic matter in them. They have a lot of fine sediments in it, silts and clays, and they've got salts in them. So another concern I have about these evaporation systems is whether they're just going to clog up with all this material that's in the water. So they have to have a reclamation plan. And I already alluded to this. I've shown you these graphics. One of my big concerns about the reclamation plan is this bentonite clay idea. I think this is a great idea. Conceptually, it makes sense. This kind of thing has been used well at hazardous waste sites, but when creating vertical clay walls, if you were going slowly and this was your main job, I think you could probably lay this clay layer down. But if you're going 10 to 15 acres a month, and your goal is really to mine mineral sands and not to place this bentonite layer, I just don't think this thing is going to get laid down in the continuous fashion that it needs to be. And I don't think it's going to work. I just don't think practically you can do that at this velocity of operation. So I'm showing you this slide to show you what happens on Trail Ridge if you don't do a good job with reclamation. So Trail Ridge has been extensively mined down in Florida between Stark, Florida and Interstate 10. And in some places you can look at where it's been mined and the reclamation looks good. Like they did a good job stockpiling the topsoils. They did a good job regrading, and the forest growth looks pretty good. But there are other places like this, and this one's only 20 years old. So this is in the modern mining area. It should work. And when you look at it from satellite image, you see a lot of white sand. And that white sand, if you don't have the organic matter from the topsoil, these sands have very low cation exchange capacity. They have very low water holding capacity, and they just won't grow trees well. And that's what you see here. The trees are really only growing in the riparian zones that were left, but everywhere where they mined, the tree growth is terrible. Now, as I said, you look at Florida where this has been done, some of these sites look good and some of them look bad. And it's really a question of the care that you put in the reclamation plan. And one of my concerns here is that the reclamation plan as written really doesn't indicate that there's a lot of care in this. So this is my wrap-up slide, and then I'll take questions and we can chat. There is a bill in the state legislature that's been proposed to basically prohibit sand mining on Trail Ridge from the southern edge of the swamp to the northern edge of the swamp. So this shows Trail Ridge, and then you can see the polygons at the top and the bottom. So under that law, the upper end of Trail Ridge north of the swamp would be okay for mining, and the southern tip of Trail Ridge below the swamp would be okay for mining. But in between those polygons, mining on Trail Ridge would be prohibited under state law. So that's, you can make comments to Georgia EPD on the mining plan, but you can also make comments to state legislators about this idea for outlawing mining sand on Trail Ridge within that section adjacent to the swamp. And with that, I'm going to go look at the Q&A and see what's on there.
Perfect. Thank you, Dr. Jackson. Yeah, I answered some of them, but left a couple for you to answer.
Okay. So I see this question from Ashby Worley. Does the mine have the potential to negatively impact drain wetlands surrounding the property site, such as on neighboring properties? I don't think so. I think one of the things that does concern me is, like, if you look at their mining land use plan, they take that pit right up to the edge of the property line. And I do have some concerns about the stability of the pit during wet periods. And, I think you could have little small landslides into the pit that might affect the neighbors. During the operation, though, I think it will lower water levels in wetlands and probably dry out wetlands adjacent, just because you've dropped the water table. So within that cone of depression of the mine, you will be affecting wetlands on the adjacent properties. That's true. Why did Georgia EPD choose the farther gauge to make it slow determination? So, Sarah, I will say that I can only give you the written rationale, which doesn't actually make sense to me. So if you look at the two gauges, they both have a common period of record from 1950 to the present. But during that 70 plus years, there's about 1,000 days where the gauge wasn't working at the ammoniac gauge. So there's basically 2.5 years missing out of the 70 years. And EPD's rationale for using the McClenny gauge is that the record is more complete, which is true, and that is of slightly higher quality, the gauge record. We got a letter from USGS says that the gauge record at ammoniac is fine and that you should feel free to use it. So I ran this issue by, at this point, 11 other senior research professors at Southeastern universities. So these are professors from Virginia Tech, UVA, Duke, UNC, Mississippi State, University of Florida, Auburn, for example. And all 11 of them unanimously said the right gauge to use is the ammoniac gauge, that it doesn't make sense to use the McClenny gauge. So this is still a question that is in action. I don't really know how Georgia EPD is justifying this. As I said, their stated rationale is length of record and quality of record. So next question, why is the red mine site on the polygon so much larger than that on the other mine sites? It also appears closer to the swamp. That's a good question. So the smaller ones are the correct ones for this mine application. The Georgia River Network map was made when the mining application was larger, and it just hasn't been revised. The other ones are the correct ones. Is the law being considered allowing mining north and south of the swamp HB 71 or another? I do not know the law's number, so I can't answer that question. Do you know, Emily?
You have to read the question. Is the law being considered allowing mining north? No, it's just there doesn't seem to be an inclusion of that northern part of Trail Ridge or the southern part of Trail Ridge. North or south of the swamp is not included. It's just protecting it's called the Okefenokee Protection Act. So it is looking to protect the Okefenokee. However, you can see the St. Mary's will be impacted at any point in between that north and south site. Our concern as St. Mary's Riverkeeper is that anything south, if the swamp is not part of the picture and they want to move south, further south on Trail Ridge, it will impact the St. Mary's River, as you will see, but not the swamp.
So Jen Fabric has this question about where the water management ponds are and the relief on the east side of the mine. So one of my concerns I didn't talk about here today is that if the evaporation plan doesn't work as designed, as of now, the mining land use plan doesn't indicate where overflow will occur. It doesn't indicate how overflows will be monitored or what they will be monitored for. So I think that's a big failing of the plan, is that no one has made any backup plan for if the water management ponds get full and they start to discharge. So I think that's a legitimate issue to bring up.
And Dr. Jackson, one thing I heard yesterday being at Capitol Conservation Day is that it doesn't also seem to be any overflow spigot for some of these ponds. So if there isn't any kind of backup pond that that's empty, and that if there is an overflow, that would be a backup pond for those overflows.
That's right. Yeah, there's no sort of backup plan at all. Right. So this mining proposal, getting to Mark's question, is for basically just under 600 acres of mining, but Twin Pines refers to this as what they call a demonstration mine. That basically this would keep them busy for 4 years. And their idea is that they would demonstrate to the state that they can do this well. And they actually have options to go north over 8,000 other acres. So what you need to think about here is that from the standpoint of the applicant, this is just their starter mine. And so you really need to be thinking about the impacts of mining 8,000 acres, not just the original 600 acres, slightly less than 600 acres. All right, that's all the open questions. Anybody else have a question or a comment they want to add? I'm looking in the chat. What's in the chat? Okay, there we go. Emily, you got anything else that you want to add while people think of other questions?
Sure. Yeah. So thank you, Dr. Jackson, for clarifying a lot of this stuff and bringing awareness to much of the potential impacts this mine may have. So St. Mary's Riverkeeper, obviously with its headwaters at the Okefenokee Swamp, and this mine impacting that southeastern corner, the lower 20% of the swamp feeds the St. Mary's. And I've been on the river several times as it passes through Trail Ridge, and have visited various spots upriver of that at various times of the year to see it at low water and see it at high water. And that 20% of the swamp is everything to the St. Mary's River. It determines the water flow, the current, the flood for that upper stretch. The other big concern is obviously Boone Creek, which flows from the mine site to the St. Mary's River directly. And Boone Creek does have an impairment on it for turbidity and dissolved oxygen. Georgia EPD's impairment list does say it's a natural dissolved oxygen impairment, along with a natural pH impairment, because it is a southeastern water body with swamp water, which naturally has a low pH. So you can find southeastern water bodies to be a pH of 3 because of that peat decomposition. But if one of the concerns is that if there is an incident that happens with this wastewater or the discharge, is that it will could potentially flow into Boone Creek and impair it even more. So you got two pristine water bodies with natural impairments. But what happens if something catastrophic happens? If we get two hurricanes in a row with a lot of humidity and the evaporators break down and we get that perfect storm? So what's going to happen to the water at that point, and its impacts on the health of the St. Mary's River, which we pride ourselves into being very pristine. Our other big concern is the water level of the St. Mary's with its flow, but also that climate change with the peat burning, that increased fire potential, and then the swamp holds close to 95 million tons of carbon. What happens if it burns and burns well? It's going to release all that carbon back into the atmosphere. Well, we got a couple other Q&As based on that.
Yep. So Mark notes that there's a bit of information overload here. Yeah, Mark, I know that, and I also went kind of fast, and I'll tell you the sad thing is I didn't actually cover everything I could have talked about. So one of those issues, by the way, is salt deposition. So when you evaporate water, only the water evaporates. The dissolved solids and the salts that are in it don't evaporate with the water. And this water is going to have a fairly high concentration of total dissolved solids. And so one of my concerns is how much salt deposition will occur downwind in the forest lands adjacent to the mine. And I've done this calculation a couple different ways and kind of got a range in values. And at the higher level, it would definitely negatively affect tree growth because you'd be putting too much salt in these soils. So that's another example of things that are issues that I didn't even really get into here. Now, Jen asked this question about the fact that hydric soils and depressional wetlands are mapped in the same areas. Well, first of all, they should be. Because all wetlands have hydric soils. The maps I would really pay attention to are the ones that were done with the on-site delineations. The ones that are done by U.S. Fish and Wildlife Service for the National Wetland Inventory, those are very sort of rough scale estimates based on aerial photography. And actually, when you get up there, you generally find a lot more than what show up in the NWI. Samuel Rowland's asking about processing chemicals. They will use some processing chemicals to try and concentrate the sands and process the sands. They usually have a sort of a small closed system for treating those waters. I don't recall seeing anything about this in their mining land use plan, how they're going to do that. So right now, that's one of the things that's kind of a black box. I did not cover this because I assumed everybody knew this. So what are they mining for? So in these old barrier islands, when you go walking on the beach, you'll see some layers of dark sand sometimes. And these dark sands are denser. And there's just this natural sort of density stratification of these sands in these old barrier islands. And the dark sands, these denser sands actually have a lot of different commercial uses. Most of this sand will be used to extract titanium dioxide from the sand, and it's used in pigments for all sorts of things that need white pigmentation, like white paint, but other things as well. But the largest single market for these sands is the titanium dioxide market for pigments. Greg asked whether the slideshow can be shared. I sent Emily a PDF of the slideshow because the slideshow itself is a really big file. The PDF, I'm happy if you share that, Emily, by the way. To the last question, there is a coalition called the Okefenokee Protection Alliance, which has a bunch of conservation groups collaborating in it, and the Audubon Society is one of those. And I'm not going to touch your question about corporations and corporate profits.
All right. Mark also said in the long run and big picture, it all comes down to who we vote for. I encourage everyone to get political and support candidates and legislators that support conservation. You got another one in there for Greg while I think about typing Mark's answer.
Yeah, so there's several different types of these mineral sands that they pull out. Some of them are used for things like high grade abrasives and industrial processing. But the vast majority of the market for this is for sands from which titanium dioxide can be extracted chemically and then used in pigments. That's the main goal. The sand itself is not titanium dioxide, but it is an ore from which titanium dioxide can be withdrawn. There will also be some of these sands will be useful in some high grade industrial ceramics. Those are really your big markets. They will withdraw some rare earths, but currently there is no US processor of rare earths. So for example, the Mission mine, the Keymores mine, they just take their rare earths and stockpile them in the hope that one day they'll be able to sell them. So I'll take any other questions that come in, but I just want to thank everybody for listening. I hope this was useful, and thanks a lot.
Yes, thank you so much, Dr. Jackson. I appreciate your time. And then just some ways that y'all can get engaged with this situation on your own. Continue participating in our webinars. Our one next week is March 2nd. It's a Thursday because our experts are professors, so they do have classes. But our professor is Dr. Lisa Chambers from the University of Central Florida, and her expertise is regarding wetlands. And so she will do a presentation on wetlands and their role in mitigating climate change through carbon capturing. So please go ahead and register for that one. The next one, the registration will come up soon. It's from a professor from Jacksonville University, Dr. Jeremy Stalker, and his expertise is the Floridan aquifer, and he'll be talking about water withdrawals and how they impact Florida and the water source. And then we're hoping to have one more before the public comment period ends, but we haven't finalized that one yet. But please like us on Facebook, social media, Instagram. It's the only two that I can handle. Sign up for our newsletters, become a member, support our efforts. And then just keep getting engaged with what we have going on. Come on one of our boat trips on March 4th or March 11th. And we hope to keep this conversation going because I know it's a lot of information, which is why we're trying to make it as accessible to the public as possible. So that way, when you do make a public comment, you are using the most well-informed information. And we do encourage, even if you are not a Georgia resident, but you are a St. Mary's River watershed resident, citizen, in Baker County, Nassau County, if you're a fisher person, please make a public comment to EPD to show that this is a border river and its health impacts 2 states. And as well as the recreational value of our beautiful river and swamp, of course. But thank y'all so much. Did we have any too much? Oh, just a lot of thank yous. All right, well, thank y'all so much. If you have any additional questions, please reach out to me. I will forward them to Dr. Rhett Jackson and he will get a response as quickly as he can. Remember, the deadline is March 20th for this public comment at 4:30. Just learned that last night. March 20th at 4:30. And thank y'all so much. Have a great rest of your day.
Bye, everybody. Thank you.
Thank you.